Okay, let's see. Guess I could have done this before I hit record, but anyways. All right, so this is a lecture on section 2.3, and in this section we're going to talk about set operations and Cartesian products. Okay, so the first thing that we want to do with this set operations section, what we're going to do, the majority of what we're doing in this section is taking a look at intersections and unions, and then how do those relate to Venn diagrams, showing them in Venn diagrams, and then also showing them by listing the elements in these sets. Okay, so the first thing that we need to do is talk about what is an intersection. So the intersection of sets can be defined this way. The intersection of sets A and B, and we write this like this: A intersect B. So an upside down U, that is our symbol for intersection. Okay. And the intersection is known as being the set of elements common to both A and B. Okay. So in set notation, it's going to look like this. A intersect B is the set of elements x such that x is an element of A and x is an element of B. Okay, so there's something really important about this here, and the important thing is the word and. The word and here tells us that we're talking about elements common to both A and B. And so if we were to draw a Venn diagram here that goes along with this situation, and we have our universal set, and then we have some set A and some set B. So I'll call that A and I'll call that B. Then when we talk about the intersection, and if we're looking at what they share in common, we're actually just talking about this region right in here. So that's the region that both A and B have elements in common. Okay. Now I'm going to label this as A intersect B, and what I want you to understand is that A intersect B is now a new set, and that new set looks like this. It has these elements right here. Now I haven't named any of these elements. I'm just showing you a region on a Venn diagram. Okay, but if we listed A and B as having elements, and I'll give you an example in a second, then wherever they overlap is what that would be. Okay. Okay, let's just do a quick example of an intersection. So let's say that I have a set A that has the elements 1, 2, 3, 4, and 5. And I have the set B that has the elements 2, 4, 6, and 8. Okay. If I wanted to find A intersect B, then I'm looking for what do they share in common? Well, they both have a 2 and they both have a 4. So the intersection would be the set that contains the elements 2 and 4. Okay, so obviously notice that A intersect B is a whole new set in and of itself, and it's containing the elements that they share in common. Okay, the next thing that we want to talk about is union. So the union of sets is going to be defined this way. We say that the union of sets A and B and this is written, excuse me, it's written with a U, so it looks like A union B. So this is going to help you to remember which one's which, as the union symbol looks like a U. So this is the set of all elements in either or both of the sets. Okay? Okay, so in our set notation, A union B is going to look like this. It's going to be X such that X is an element of A, or X is an element of B. Okay, and again, the key word in this one, and when we're talking about unions, is the word or. All right, let me give you a Venn for this. So a Venn diagram for this is going to look like this. I have my universal set, and I have A and B. I'm going to actually label them on the outside here. Because when I talk about the union of these, I'm talking about whatever they share in common, but also whatever they have on their own. So I would actually shade everything in B, everything in A, and everything they share in common. That right there is representing the union of A and B. Okay? Now, let me give you an example, and then I'm going to talk to you about the difference and how to understand the difference. So if we just went back to this example that I put up earlier, where we have A equaling 1, 2, 3, 4, and 5, and then B equaling 2, 4, 6, and 8. Okay, and last time we looked at the intersection. This time let's look at the union. So if I take a look at A union B here, I'm combining these two together. All right, so I'm going to be saying I have 1, 2, 3, 4, 5. That's all of the elements in A. And then I'm including all of the elements in B in here. I'm just sticking all of them together into one set. Now, if there's repeat elements, I don't need to list them again. Okay, you only need to list them once. So the union is this new set that contains all of them. Okay, so, you know, a lot of times people get these confused. The or and the and you know, how to remember the difference. And I always use the example of a peanut butter and jelly sandwich. Okay, so think about it, what it means. If I ask you to bring me a peanut butter and jelly sandwich, I'm actually asking you to bring me a sandwich that has both, right? I want both peanut butter and jelly. I want the situation where I've got both of those things. That's what the word and means to us, okay? If I say to you, can you bring me a peanut butter or jelly sandwich? Then I'd be happy with peanut butter, and I'd be happy with just jelly, just peanut butter, or I'd be happy with both. Because if you brought me a peanut butter and jelly sandwich, that's the same as having a peanut butter or jelly sandwich, right? It's got one or the other of them. It's actually got both of them. So the word or means that you're more willing, you've got more flexibility. You can give me peanut butter, you can give me jelly, you can give me both, that's going to work. If I specifically say I want peanut butter and jelly, I want both of them. Okay, so that's where this example over here. Okay, so let's see. So the next thing we need to talk about is the difference of sets. And, the difference of sets is basically what you would expect it to be. The only thing here is you have to make sure that you get the order correct. So we say this for the definition. The difference of sets A and B, and this is written as A minus B. This is the set of all elements belonging to set A and not to set B. Okay? All right, so in set notation, that's going to look like this. It's going to be A minus B is going to be the set of elements X such that X is an element of A and X is not an element of B. Okay, so it's what you would expect. If you're working with a set A and you want to subtract off the set B, then you're just going to take away whatever's in B that they share in common. Whatever it is that they share in common, you're taking that away from A. Okay, so it's whatever's in set A and then not in B. So to give you a Venn diagram of this situation as well, kind of running out of room on this page, but those are supposed to be circular. You got to humor me on that, right? So this is A and this is B. And if I'm looking at X being an element of A and not being an element of B, that would actually be all of this right here, wouldn't it? Because if I shaded this region right here, if I shaded this middle region, those elements are going to be elements of B. And when I do a subtraction, I'm taking all of those elements away. Okay, so this right here is going to represent, is going to be the Venn diagram for A minus B. Okay. Let's do an example of this. And so I guess I'm using the same set. Well, I guess it's a little bit different. So set A is the elements 1 through 6, and set B are the elements 2, 4, 6, and 8. Okay. All right, so let's go ahead and calculate A minus B. So what I'm doing with A minus B is I'm just looking at the two and I'm saying, you know, whatever elements that are in B that A also shares, I'm going to take them out of A, and that's going to be the difference here. So this would be the set, it would include 1. I would take away 2 because 2 belongs in B, right? So I'm trying to not have elements in B in this new set. And then I would have 3 and I would have 5. Now I don't include the 8 because that's a part of B and I'm looking at taking away B. And there's no 8 in A. So A minus B here is going to be 1, 3, and 5. Now what I want you to take a look at is this right here. So go ahead and pause for a second. I'm going to ask you to do this as we go through these lectures, where I'm going to ask you occasionally to try some things on your own before I go through them. And in class, I just wait and allow people a few minutes to try them. But in these videos, what I'm going to do is I'm just going to ask you to pause the video and then try something on your own. And then you can hit play again and I'll be doing it. I'm just going to immediately lecture it through. So if you don't want to try it on your own, I guess you don't have to. But it is helpful if you try it on your own first. Okay, so if you could hit pause and try B minus A on your own first, and then hit play when you're ready to see the answer. Okay, so B minus A, what we're doing is we're doing this the other way around. So I'm taking a look at whatever's in A that exists in B, and I'm taking it away. Okay, so A has the element 2, so I would take that away. And B has the element, or excuse me, A has the element 4, and A also has the element 6. So all of these elements, 2, 4, and 6, would be taken away, and B minus A would just be left with the element 8. Okay, now this is an important thing for us to note here, that A minus B and B minus A are not the same thing. And that should be intuitive to you because because this is the same thing in regular math, right? A minus B is not the same thing as B minus A when we're just working with numbers, because the minus sign is here, the B is negative and here the B is positive, so it's just not the same thing. Okay, and this holds true for sets as well. So A minus B is not equal to B minus A in sets. Okay. All right, let's do a few examples where we are working with the sets and some of the notation. So what I'm going to do is I'm going to let, let's see, I'm going to get a new piece of paper. I'm going to let U, the universal set, be the set containing the elements A, B, C, D, E, F, G. Okay. And then I'm going to let X be the set containing A, C, E, and G. And then Y is going to be the set containing A, B, and C. Z is the set containing B, C, D, E, and F. Okay? All right, and then we're going to run through a bunch of problems here. So let's try this example right here. Let's say that we want to take a look at X, the union of X and Y. Okay, so the union of X and Y would be taking all of the elements in X, all of the elements in Y, and sticking them together into a new set. So it would look like this. Everything in my X, A, C, E, and G, and everything in my Y. So this is going to be A, B, C, E, and G. Okay. I keep wanting to ask if you have any questions because I'm lecturing, but I'm not in your presence. So, okay, let's try another one here. Let's try this. X naught intersect Z. So, you know, this, as we get more difficult in these problems, we're going to have to do multiple pieces. So as you can see in this problem, we want to try and intersect X naught and Z, but we don't know what X naught is yet. So what we need to do is we need to first of all calculate X naught, and then we can take that set and intersect it with the set in set Z. Okay, so remember what X naught is. X naught is going to be everything that's in the universal set that's not in X. Okay, so if you take a look at this, we have the universal set A, B, C, D, E, F, G, and X is A, C, E, and G. So whatever's in here that isn't in there, it's going to be B, D, and F, it looks like. So X naught is going to be B, D, and F. Okay? All right, now I'm going to take this and I'm going to intersect it with Z. So X naught intersect with Z, you have to remember what intersection means. You're looking for what they share in common. Okay, so my X naught has a B, and so does my Z. So I've got a B, I need a B in here that they share in common. My X naught has a D, and so does my Z. So they share in common a D. And my X naught has an F, and this has an F. So they actually share in common those three elements. Okay? All right, let's try another one. I'm going to fold this. So we're going to keep working with those. So I guess you'll be able to see it. Let's try this one here. So this is X naught union Y naught, and then we want to union that with Z. Okay, so again, you know, we know X naught, we just did that one. We need to find Y naught, and then we need to find that union. That's what these parentheses mean. We need to do that first, and then we'll take that result and union that with Z. Okay, so our X naught from, we just found it, is B, D, and F. Okay. Our our Y naught is going to be everything that's in the universal that isn't in Y. So this is A, B, and C. So Y naught is going to be D, E, F, and G. Okay. Now, if I take the union of these two, remember what union is you're sticking them together. So this is going to be this right here. X naught union Y naught is B, D, E, F, and G. Okay? And then I'm taking this right here, this result, and I'm unioning that with Z. So that's unioning it with this. So X naught union Y naught, union that with Z, is going to be the set containing the elements, all of these and all of these. So we have B, C, D, E, F, and G. That would be the answer right there for that one. Okay? All right. I want you to take a moment and try this next one. Okay, so let's see. Give yourself a moment and see if you can try this on your own. Okay. Okay, and so pause it and try it. And I'm going to go through it. So we have y intersect x naught is what we're going to have to do first. We have to do the inside of this first. Okay. All right, well, we know x naught. I'm just going to write it down again. X naught is B, D, and F. Okay, so X naught is B, D, and F. And if I take my Y and I look for the intersection of these, then I'm looking for what they share in common, and it looks like actually the only element that they share in common is B. Okay, so Y intersect X naught is actually just going to have the element B in it. Okay, all right. What I need to do next is I need to look for the naught of that, right? Because this says Y intersect X naught, but then we're naughting that. So what this is saying is whatever set you came up with for this, when you naught it, you're going to be looking for everything that's in the universal set that's not in this set. So when I take Y intersect X naught and I naught it, it's going to be everything in the universal that isn't B. Okay, so our universal again was all of this. So this set is going to be A, C, D, E, F, and G. Okay. All right, so we keep assembling this. This piece now, I'm going to try and union that with Z naught. Okay, so we first of all need to find Z naught. I think I'll write Z naught up here. So Z is B, C, D, E, F. Z naught then is A and G. That's what it's missing from the universal. Okay, so when I assemble this, Y intersect X naught, naught union Z naught, I'm taking this set and this set and I'm trying to put them together, right? Because I am talking about a union here. So that's going to be the set, and A and G are actually already in here. So A, C, D, E, F, and G. Sorry, I have a watch that has an alarm that goes off that I don't know how to silence. So it does this every day at this time. Okay, so that's our answer to this particular problem. Okay, next thing I want to do is some Venn diagrams. So we're actually going to do the same thing that we've been doing, this type of thing, but instead of working with the actual elements, we're going to take a look at what the pictures of these would look like on a Venn diagram. Okay, so let's warm up with a problem. This problem right here. It says that the directions are for us to place the elements of these sets in the proper locations. Okay, and that's the proper locations on the Venn diagram. So my universal set has the numbers from 5 up to 13. Okay, and my set M has the elements 5, 8, 10, and 11. And my set N has the elements from 5 to 10, but it's missing the 8. Okay, so if I were to do a Venn diagram picture for this, and I've got my universal set, and I've got the set M and the set N, and now I know that I'm going to show M and N intersecting here, and the reason that I'm going to show them intersecting is because I see right away that they actually share some elements in common. They share the 5 and they share the 10, which means that they're going to have an intersection point. And at that intersection point, I'm going to show the 5 and the 10. Okay. So these are the elements that they share in common. And then if I take a look at what M has that N doesn't have, that would be the numbers 8 and 11. Those numbers are going to go over here. They're going to go in the region that M contains that isn't a part of N. Okay? Same thing with this here. N contains the elements 6, 7, and 9 that M does not have. So those elements are going to go in that region. Okay, and then the last thing to do is take a look at what does the universal set contain that isn't in either M or N, because those elements are going to go on the outside of these two circles. Okay, so if I say here I've got, it looks like I have 5, 6, 7, 8, 9, 10, 11. I'm missing the 12 and the 13. So the 12 and the 13 are going to go on the outside there. Okay. All right. So let's do a few Venn diagrams for just the without elements in them, just the shading. So we want to shade the, I don't want to say this, shade the appropriate region. Not appropriate, shade the indicated region. Okay, so let's try this one. Let's start with A naught union with A. Now, when I teach this in the classroom, I use color, and unfortunately color doesn't really show up very well on this this webcam, so I'm just going to have to show you with the hash marks what's going on. Okay, so we're going to start with the universal set, and I have a set A here. Okay, and what I'm trying to do is I'm trying to find A naught union with A, and I'm trying to show a picture for this set, whatever this new set looks like. Okay, so what I'm going to do is I'm going to start to build this, and the first thing I'm going to do is I'm going to show a picture for A naught, because I see what A is. A is this, that's this set right here, and all the stuff on the inside, and so A naught would be everything that's not in there. So to show that in a picture form on a Venn diagram, it's going to look like this. If I shade everything on the outside of A, that picture right there is showing me A naught. Okay. Now, if I then want to take my A naught, which is all of this shaded region, and I want to union that with A, and A is this region that isn't shaded, then you can see that the shading that I would have, and by the way, I guess I didn't say this, but when you shade, you're showing the region that is part of your solution. Okay, so, or you're showing your ultimate solution here. So A naught, you know, is represented by all this shading. If I union that with A, I would actually shade in here. And so I use an arrow here to indicate, I guess, that we're coming down here. And A naught is all of this, right? When I union that with what's in A, then this becomes my picture. A naught union A. Okay, shades everything. Take these two, remember what union says, take these two and combine them together. Okay? All right, the rest of these problems, we're going to have the same directions. I'm just not going to write them. I'm not going to keep writing them. Shade the indicated region. Okay, so let's try this problem right here. Let's try A naught intersect B naught. Okay, so the first thing we need to do is show A naught and B naught, and I'm actually going to show them on the same Venn diagram. Okay, so if this is my A and this is my B. All right, so A naught is going to be everything on the outside of A, everything that's not A. So it's going to be represented by all of this. Now, notice that there are some elements in B that are shaded, but there's some elements in B that aren't shaded. And the reason for that is the elements in B that are shared with A are not shaded, because I'm talking about this that I've just highlighted here as A naught. Okay? So I really don't care what's going on with B when I shade A naught. I just shade A naught. And however it affects B is how it affects B. Okay. Now, I'm also going to shade B naught on the same diagram, and I'm actually going to draw pictures, lines going this way to show B naught. Okay. So let me write this down. Actually, what we have right now is A naught. B naught is going to be everything on the outside of B. So it's going to be all of this stuff and all of this stuff in here. Okay. So that's everything on the outside of B. Now, what we're looking for is the intersection. Okay, so we're looking for what do these share in common? Where do they overlap, essentially? Okay, and when you do these drawings and you're looking for an overlap, you're actually looking for a crosshatch region, because that's going to be the region where you have both A naught and B naught. And so I don't know how clearly you can see this. This is a very visual thing, and you're going to have to practice it. But all of this region out here, all of this region outside of B, and all the region outside of A is all crosshatch. There's no drawing in here at all. There's no crosshatch here, and there's no crosshatch here. So when I go to take a look at and assemble my A naught intersect B naught, is going to look like this. I've got my A, I've got my B, and A intersect B naught is all of this stuff out here. Okay. All right. Let's try another one. And I want you to give this one a try on your own for a few minutes. So after I write it down, go ahead and pause the video and try it yourself. And this one has 3 sets in it. A intersect C naught union with B. So the basic Venn diagram that you're starting with is a Venn diagram that has an A, a B, and a C in it, like this, all overlapping like that. Looks something like the Olympic symbol or something like that. Okay, so go ahead and pause the video and try it. All right, so I'm going to go through this. The first thing I'm going to do is identify C naught. Okay, so C naught in my diagram is going to be, everything that's not C. So it's all of this stuff on the outside. And I'm kind of a little low there, but, right? So everything that's not C is that. And then what I'm going to do is I'm going to intersect that with A. So A is all of this stuff and all of this stuff as well. But if I show the intersection here, I'm hoping that you can see that the intersection, what they would share in common, would be this region right in here. All of this stuff that is shaded but is not in C. Okay, so in my next step on this, A, B, and C, in my universal set, A intersect C naught is actually going to be this region right here. It's going to be everything, everything that is not in C. A intersect C naught. So everything not in C, but that is in A. Okay, so that would be this region right here. Okay, and then what we need to do next is union that with B. Okay, so everything in B is going to get shaded in that isn't already shaded in. So it's going to be all of this region here. So we would say A intersect C naught, union that with B. Excuse me, I need to take a drink of water. My mouth is really dry. Okay. Excuse me. So this is A, this is B, and this is C. So if we're taking this, which is A intersect C naught, and we're going to union that with B, then we're taking everything we had before, and we're unioning it with B. So we're going to include everything that's in B. Okay, so that would be your answer for that one. Okay, and that's it.